I'm here at UDS with Dustin Kirkland. Dustin, we're in Copenhagen, Denmark this time.
A little bit cold, huh?
It is a little cold. You're the CTO at Gazzang. Previously, you've been with Canonical, and I've had the opportunity to interview you in that role. But what exactly, for those who don't know, what is Gazzang and what do you do there?
Sure. So Gazang's a startup based in Austin, Texas, where it's a lot warmer than Copenhagen right now. Gazang essentially provides three products. One is an open source, a commercially supported version of the open source encrypted file system eCryptfs, and we'll soon support decrypt as well. But our goal is to help companies and individuals, small, medium business, all the way up to enterprises, secure their data at rest. The second piece to that puzzle is the key management. Key management involves storing the keys somewhere separate from the encrypted data. And then our third piece of the triangle right now is a monitoring and diagnostics utility that gives a system administrator introspection into what's going on in their system. So Gazang's a software company producing and supporting those products, and we've got over 100 customers.
I know that you have this overwhelming just passion about data encryption, and that was evident on the Ubuntu side of things. As an average end user, Ubuntu makes it really easy for me to encrypt my home directory. I don't know that I would be able, I probably could figure it out if it was another distribution, but because of the work that you did while at Canonical, it's very easy for any user to choose that option and do that by default. But why is it important that me or any other average end user care about encrypting their data?
Devices disappear. It just happens. I'm sure you know someone, or you yourself have lost a phone or a laptop. Maybe you just had an old computer that you donated to Goodwill or gave away to a school or a classroom. Did you wipe your data? Did you wipe it well enough to really cover all of the information that might have been on that? Your cookies in your browser are sensitive, not to mention your documents, or if you've got a document with all your passwords in it. Devices disappear, and if they don't disappear, they get recycled or reused. That's a real important consideration. Within Ubuntu, as you mentioned, we've been extremely lucky for the last 4 or 5 years. It's a one-click, please encrypt my data, and it uses eCryptfs underneath the covers to do that. Not everyone has that opportunity to do that and make it that easy. It's in particular, it gets more important on servers than desktops, when you start talking about data at scale. But even for a home individual user, if you're not going to have this device forever, you're going to lose it or give it away, donate it one day, your data really should be encrypted on it.
Which brings me up to another point. You mentioned, data on servers is different than desktop. So what are the different considerations that you look at with encryption on those different devices, be it desktop, laptop, tablets, phones, or what the list goes on, especially now that the desktop has changed from something that sits on your desk to something you hold in your hand virtually.
Yeah.
So what do you have to think about when you're looking at that?
Well, first, I just want to remark on that list of devices you mentioned. Every one of those Linux runs on, and now Ubuntu runs on in one form or another. Desktops, laptops, tablets, mobile devices, and servers, physical and virtual. We've come a long way in the last 4 or 5 years that I've been involved in Ubuntu to see Ubuntu across that entire suite now. But that with the consumer level devices, the desktop, laptop, tablet, and mobile, they're a lot easier to lose. It's something that you have in your, do I have it in my pocket? Where? Nah, just kidding. But you lose your phone, you lose your laptop. It's also important to understand that there's not as much CPU or power behind these mobile devices. The disk is really slow. It's a flash, usually flash media, which isn't as fast as some spinning media. But the most important difference is that there's always user interaction with those consumer devices. You're there at the device. If you're trying to use it, you're there at the device. You have the opportunity to type in a PIN or a password or draw a pattern or input some piece of unique information that right? With a server, a few of those things are quite different. You don't typically lose a whole server, but you do lose hard drives. When it comes to a server, the back-end storage is this vast array of thousands of disks in some cluster, and there's lots of different cluster file system technologies today. But those disks usually sit in a data center next to the server. They're not even in the same physical chassis that the server is in. Those disks go down. I mean, there's a bunch of green lights and one red light. And the one red light flashing is the disk that's dead. And the sysadmin pulls that one out, puts it into a return to manufacturer envelope, puts a new one in, and goes about his day. And he does that dozens of times per day in a big data center. And that disk, what happens to that disk? You know, it may get repurposed, reused, recycled, returned to manufacturer. And if your data was stored on a server in a cloud, maybe it was a big data application or an OpenStack cloud or something like that, one slice of your data probably existed on that disk. If it wasn't encrypted, someone has access to that disk. You know, it's important to understand that. Now with servers, there's a lot more CPU and a lot faster storage, so you have, you know, an opportunity to do, you know, throw a lot stronger encryption at that. And typically the data stored on that is, you know, no offense to you or me, but more valuable, you know, in aggregate than the information that you and I might store on our devices. But the biggest difference and the most important consideration was the last point I made about the consumer devices. With the consumer device, you're at the device and you can type in some piece of information. With the server, you've got hundreds or thousands of these, and there's no individual admin who's physically connected to that device. And so that server needs to store these passwords or passphrases, these certificates, you know, its piece of secret information somewhere other than on the device. Otherwise, the attacker has everything they need to get the data. And so that's where key management really becomes the big problem. Where do you store the keys, essentially? How do you get to those keys?
And is that not distilling down everything, all the problems that are out there around data encryption? I mean, you make it sound like Gazzang has solved all those problems, but is key management not ultimately distilled down the real problem?
You've got it. Yeah, key management's the biggest issue. Encryption is the easy part. In fact, you know, you mentioned Ubuntu having the one-click encrypt my home directory. That problem is solved essentially for Ubuntu desktop users. Even Ubuntu server users can run the same script, you know, and essentially set up the same thing. But that kind of glosses over the real problem, which is where do I put my key? When it's your desktop, you type in your password, and that decrypts a file that has a big, long, randomly generated password, which is the actual encryption password. You can't type in that password on every single server in your giant Hadoop cluster, for instance. And so that's what we call the key management problem. So when it comes to key management, the idea for servers, at least from Gazzang's perspective, we do have a product called ztrustee that solves this for Linux-based server systems, you know, cloud, big data, Mongo, Hadoop, Cassandra, all of these. You know, we're putting our encrypted file system, which is essentially eCryptfs, with some configuration utilities and best practices. We configure it in a way that we think we know is most secure, that your data will be protected with strong access controls, that we can support and help you get your data back, you know, in the event of a disaster. We've also certified it and benchmarked it with all of these applications, and along the way we've had to fix bugs, you know, issues with eCryptfs where it didn't work as well with MongoDB, for instance, out of the box. And so we've fixed those bugs, we've submitted them upstream, and so forth. But the real fundamental, and you could have done, I guess, most of that with eCryptfs or DMCrypt or TrueCrypt even, for that matter, below it. But where do you put the keys? And that's where Gazzang's second product comes in, ztrustee. So ztrustee is a client-server model. It runs extremely well on Ubuntu. We use Ubuntu across the board to do our development. All of our development, you know, our developers run Ubuntu on their desktops and in the cloud and so forth. I mean, we support other Linux distributions too, but you know, my heart and passion's always been Ubuntu. The way that the key management server works, you know, you've got these clients. They're actually servers, but we'll call them clients here, that need to do the encryption, and so they fetch a key from the server. Actually, they put it there first, and then they get it later. It's the two fundamental operations, put and get. Those put and gets happen over an SSL encrypted connection, obviously. We always use real certificates, so there's never the, do you trust this certificate, are you sure? No. We use real certified signed certificates. And then over that SSL connection, we then have a RESTful web service for fetching and putting these keys. And inside of that is a wrapped GPG signed and encrypted blob of data. It's actually JSON inside of that. Maybe we're going too deep on the crypto, but I think some people may appreciate understanding how it works. Inside of that signed encrypted blob, when you're putting, is your actual signed encrypted data that goes in and stored on the server in the assigned manner. It's asymmetrically signed and encrypted so that only you can read that data later. On the put, the client defines a list of policies by which either this client or another client can retrieve the data, and the server enforces that policy. So you can define things like a time to live, an expiration essentially on the deposit, the number of times it can be retrieved. You can have like a one-time password or a 10-time use token. But most uniquely, and I think really the heart and soul of ztrustee, the coolest part about it, is what gives the name trustee in there. So a trustee in financial terms is a person who has the right and the responsibility to sign on the dotted line to release funds to a trust fund, baby, right? Well, in this case, the funds are the actual secure deposits, and the beneficiary is the client that needs access to that data. So the client can say, I need the key number blah, and it's a long random 256-bit random string, and the server says, I know that one, let me make sure it's not expired, that it hasn't been retrieved more times than necessary, that the request is coming from an authorized client who's also not expired and hasn't had their key revoked. This is 5 of about a dozen checks or so we institute. But also, let's see if any trustees are required to sign off on it. And when that deposit was put, you could have listed 1 to N, let's say 5 trustees who need to sign off on the release of that deposit. And you can define how many of those need to vote yes to do so. So let's say it requires 3 out of 5 signatures. Each of those trustees will receive a signed encrypted either email message or a notification to their Android phone. We've got an Android app as well. The app on your phone will buzz. Maybe you'll get, on my phone will buzz. Maybe you'll get the signed encrypted email, and we're in different parts of the world. Each of us see that, and we're not sure about this. Well, I wonder why these servers, need their access to their keys. Let's bring up IT. Oh, there was a power outage on the East Coast because of the hurricane this week, and now they're just bringing them all back up. Okay, so I should go ahead and authorize this deposit. Okay, good. What we've just done is an out-of-band check that no server could have done by itself. So we click approve, you click approve, and assuming our third trustee also clicks approve, the server then releases that key to the client decrypts it, checks the signatures, and then uses it to maybe mount a hard drive or something like that. If any one of us would have said no, that would have terminated that request at that point, and we could have actually injected some really strong access controls in the middle of a process that has to be automated to some extent, but as soon as you do full automation, you give up some of the human checks. So that's a long-winded answer of how we've solved the key management problem, but we think we've done a pretty good job with it.
To me, it all sounds like, as you were speaking, I'm thinking of all these different use cases where that would be really important. And I don't know if you can say this or you can tell about that or give the specifics, but have you seen an example of where that solution has saved the day for a company?
Good question. So the product's pretty new, and we're using it internally ourselves. Most of our customers are in a couple of different vertical stacks, usually healthcare, finance, and student records. The ztrustee server is now part of our encryption offering, so anyone who buys the encryption offering gets the ztrustee server. We typically only hear about things when things go wrong, but most companies don't like to make a lot of noise about something. When our stuff goes wrong, we don't usually hear about it. So unfortunately, I don't have a fun anecdote for you there yet. Anyway, we respect our customers' privacy from that perspective. But I mean, let your imagination run wild. I think you can see how this is interesting or useful. I know that I want my healthcare records protected. Those of my family, my wife, my daughter. I want that. We're just streaming this information into our doctor's offices, our hospitals, and you don't have really any access controls. Imagine you being the trustee of your own data. When a doctor asks for your records from your X-rays, you get that notification on your phone or your email, and you click the authorize or deny. Yes, authorize whatever dermatologist to access these records because they need to check check this biopsy or something like that. That seems pretty compelling. That's not quite where we're at now, but that's where I see taking this technology and this idea, this concept.
It's all exciting, and I remember when I first heard that you moved over there, and the job that you were doing. I think I interviewed you right after you were hired there, and it kind of out of the peripheral, watching the growth and your movement into different positions and stuff. And so congratulations on becoming CTO. Is there anything that I haven't asked you about that you would like to tell people about now?
Kind of long-winded, so I've talked about a lot of things. No, I mean, it's great being here at UDS, seeing the Linaro Connect and the Ubuntu Developer Summit. I'm extremely thankful that I'm able to continue participating in this. Gazzang's a small company. I wear a lot of different hats. The ability to take this time off and get away a little bit. I certainly thank my team and my management team for covering for me. But Ubuntu is important to us. Open source is important to us. Linux is important to us. The kernel is important to us. We contribute little bits along the way. We maintain eCryptfs. We want to be a good open source company, a good open source citizen. That's part of the technical strategy I've laid forth as CTO. I look at the biggest companies that are really successful right now. Companies like Cloudera and Tengen and Canonical and Red Hat. Companies that have been successful in the past, like MySQL. There's an open source product at the heart of every single one of those. And then when you go from the companies that are on that sort of upward trajectory to the ones that over time have become incredibly successful, like IBM and HP, Intel, Linux is still near and dear to their heart as well. So I see that personally as a technical leader in our company. That's the wave of the future. That's where this is going. We talked about laptops, desktops, tablets, mobile phones, servers, cloud, big data. There's a Linux kernel at the heart of every single one of those. There's a Linux stack of operating system utilities sitting just on top of the kernel there, and then some awesome open source applications built on top. I think we're in the middle of really exciting times right now, and I'm glad Gazzang is participating in one small part of it. That's the encryption, key management, the security space. It's a slice of the pie, but the pie is huge right now.
And while I know that I think you're the most passionate person I've ever met about data encryption, I assume there's many out there who's just as passionate and excited about it. How do people get involved, or can they get involved? Is there a community around Gazzang, and how do they get involved with it?
Yeah, so we use Launchpad, Launchpad and Bazaar for all of our utilities. Most of what we do is open source. eCryptfs is the best place to get involved. We've got a couple of, I'd be disingenuous if I didn't mention we've got a couple of proprietary wrappers. Mostly it's around managing the licenses for our commercial products, but eCryptfs is a 100% GPL v2 solution. eCryptfs utils is the user space. eCryptfs on the kernel side. Tyler Hicks works for Canonical. He's the kernel maintainer. Awesome guy, longtime friend. He definitely needs help on the kernel side. My kernel skills are aging rapidly, and I can't help him as much as I should anymore. Get involved in the file system devel mailing list, the eCryptfs mailing list for the kernel side. In launchpad.net/eCryptfs-utils is the upstream project for the user space. Come help triage some bugs. We got plenty of things to tackle there. And then we've got a list of projects that we or I work on at Gazzang as a team. SSH import ID is how you import IDs, public SSH keys. Overlay root is an awesome solution for cloud that combines overlay FS and dencrypt. That came about just this year. We announced we're actually working on a public key server, a replacement for SKS, synchronizing key server, something that one of my colleagues, Casey Marshall, started in his spare time to scratch an own itch. I mean, that's the old, how do you start an open source project? Well, you scratch your own itch. We had some problems with the SKS, the synchronizing key server. It's the public key server behind GPG. So Casey started a project called Hockey Puck. It's a play on the protocol. HKP is the protocol, HTTP key protocol. He started a new project called Hockey Puck, and it's written in Golang. It's built on top of MongoDB, and that contrasts with SKS, which is written in OCaml and Berkeley database. So this is a little bit more modern take on it. But we're just now picking up that work and going to contribute to it as Gazzang, as well as Casey in his spare time. So again, launchpad.net/hockeypuck. You can always find me on IRC. I'm Kirkland, Kirkland on IRC, and I've got pet projects. Gazzang has projects. Ubuntu has projects. If you want to get involved, it's not hard, and I'm happy to coach someone as well.
Dustin, thank you so much for sitting down with me again at this UDS. I always look forward to speaking with you and interviewing you. So thank you, and I hope to see you at the next UDS.
Always a pleasure, Amber. Thank you.